So when I put the acid crystals on my tree, it looked lovely, but it melted my tree.
Yeah, it would. I was only joking.
Ah, but it's okay. It didn't catch fire.
It didn't.
In case you're wondering.
You're really lucky.
Yeah, because the tree was just covered in PCB, which is also terrible.
PC.
Oh, I'll tell you a bit later.
Okay.
Okay, so now we're going to explain a bit more about why stuff happens with other cyclics, but not benzene.
Cyclohexene, for example. It's got the hexagon, just like benzene. It's got a double bond, just like benzene looks like it does.
Yeah.
But if you put bromine, what am I doing? Plus bromine into that,
it will decolorise bromine water, whereas benzene won't. And this is why. So benzene hasn't quite got double bonds, it's got sort of 1.5 bonds. And that basically means it hasn't got anywhere near the amount of electron density as cyclohexene.
So this will make more sense if we quickly go through the mechanism of the addition reaction you did at AS. We're not going to go through all of it, because you should know it, but...
So we have our two BRs, and when they go near to this double bond, the charge gets pushed from the one closest to the one furthest away, so that one becomes more negative.
It's like putting a magnet near a magnet with two north poles that's going to push away.
They're going to push away, exactly like that.
So this is going to become
and this creates dipoles.
Slightly negative.
And this will cause a reaction that you learn in AS, because this is positive, this is negative, this will become this will add, and it will remove hydrogen and all that jazz.
So if we do the same thing with benzene, sorry. We've got the same double bond, we've also got one here and here, but they're not really double bonds.
No, they're not really double bonds, it's just a circle. So what happens here is there actually isn't enough negative charge to push, like the north-to-north magnets, away that doesn't actually make any dipoles, and that's why nothing happens.
Yep. But if you attach it to a halogen carrier, either iron or aluminium, so you have your FeBr3, that's a B I promise, this is an FeBr3, as we did in the previous video to this, then it will work in a very different way to this.
It will. And that's that sort of thing, but I said I'd mention PCB. Yeah. And that's a very snazzy chemical made with, it's actually 2 benzenes, and they use it in lots of things. And you need to know that it's really bad.
It is really bad.
It's kind of like the A2 equivalent of CFCs. So they say CFTR protein, but that's not the same thing.
So it's biology.
That is biology.
It's something like that.
It's something like that, but they've both got...
some things.
Well,
I don't think it's got that.
I think they just have the circles because it's benzene.
Oh, true.
And it's like this. It had loads of uses. It was used in carbon stuff.
I'd imagine it's used in paint and
and
stuff.
it's really not flammable.
Yeah, it's not flammable.
But it kills penguins. We're not having that, are we?
No. Another problem with it is why did you have your Christmas decorations up? It's November.
Oh well, yeah, I was getting an early bird.